All right, guys, I'm just doing this video to give you something to reference if you get stuck at any stage of the sub-assignment for today. So I'm just going to do one problem from the yellow section, one from the green section, one from the orange section. And I do need you to do one from the red section. I'm not going to do a video on those, but challenge yourself and see how you do. All right, you should be able to get them. They're not so bad. Okay, let's start off with one of these in the yellow section. I'm going to pick number 6. All right, so I'm choosing number 6, which means you cannot choose number 6. So if the one you were planning on doing was number 6, I'm sorry. All right, you got to pick 2 of the other 5 to do. Okay, so remember, the first thing you need to do is, just like we saw in the colored boxes exercise yesterday, what you're going to do is break down everything you can. And in this case, you don't have any polynomials, but you can break down the numbers. So this number 10, I'm going to write as 2 times 5 instead. So my numerator there is 2 times 5 times p. My denominator is just 5. That's a prime number. You can't break that down. Rather than divide, I'm going to multiply, and that means that I'm going to flip this fraction and use its reciprocal. So my numerator is going to be 10, which is another 2 times 5, and my denominator is going to be 8, which is 2 times 2 times 2. All right, so many of you could probably do this very quickly. I'm taking the long way because I'm showing you if you do get into a case where you have huge numbers or huge expressions, this is all you need to do to break them down. Just factor them. Whether it's a number or a polynomial, you just need to factor it. So now what I'm going to do is I'm going to condense all of this. Since it's multiplication, I can combine all my numerators. So I have 2 squared in my numerator, I have 5 squared in my numerator, and I have p in my numerator. And then in my denominator, I just have a 2 cubed and a 5. And now I can cancel, all right? How many 2's can I cancel? I can take 2 from the numerator and I can take 2 from the denominator, but that's going to leave me with a 2 to the first in the denominator. I can take 1 5 from both the numerator and denominator, but that's going to leave me with a 5 in the numerator. And there's nothing I can do about that p, so I end up with just a 5p in the numerator and just a 2 in the denominator. And now it is totally simplified. Okay? So 6 is off the table. Don't do 6. But you want to approach 1, 2, 3, 4, or 5 in the exact same way that I approached number 6. All right? Let's check a green one. I'm going to pick one that involves some different types of factoring, I think. Okay, let's do 27. So 27 is off the table. You can't do 27. Remember, what I want to do here is factor first if I can. My numerator of the first expression, or the first term, cannot be factored, so I'm going to leave that as n minus 7. But my denominator could be factored if I use the Gcf method. And then another thing I can do here is I see that I've taken a 6 out. I don't know if this is going to be useful or not later on, but what I'm going to do is rewrite 6 as 2 times 3 and just completely factor everything. And then I have times, so I don't need to flip my fraction. Again, I have a GCF of 6. And when I pull out that 6, I'm going to have a 2 minus n. And in my denominator, I have to try to find a way to factor this. So I'm going to use n minus 7 and n minus 6. I'm double bubble using the AM method here. All right, now everything is totally factored. So what you could do is you could write it again, and you could put it all together as one fraction like I did in the last example, or you could just recognize that that's kind of a waste of time, right? If I'm multiplying 2 fractions, all the numerators of both of those fractions are really just one numerator, and all the denominators of those fractions are really just one denominator. So what can you cancel? N minus 7 divided by n minus 7 is 1. I have a 2, a 2, a 3, and a 3. All right, that's pretty nice. Now we have to discuss this 2 minus n over n minus 2. So you would probably say those are not the same thing, and I agree. They probably are not the same thing. But if I rewrite this 2 minus n by factoring out a negative 1, I'm going to have negative 2 plus n, which could be rewritten as negative 1 times n minus 2. So I really do have an n minus 2 here, just like I have in the denominator. The only difference is when I cancel these two things, I have to leave that negative behind. So 2 minus n divided by n minus 2 is negative 1, not 1, and that's why. All right, so our final answer then here is what's left in my numerator. Well, just a negative 1, and in my denominator, all that's left is an n minus 6. So now that is fully factored. All right, and that's an idea that is going to pop up in a couple more of these, so it's a good example to do so that you see how to do that division there. All right, so 27 is off the table, and I'm going to do one from the orange section as well. Let's do 39. All right, so this is a good one because it's a division problem, and it also has a bunch of different types of factoring involved. Okay, so first thing I'm looking for is Gcf method anywhere that I can do it. So that's the first thing I'm going to do here. I'm going to pause the video. I'm going to use the Gcf method anywhere that I can, and I'm also going to turn this from being a division problem into being a multiplication problem. All right, so now just take a look at the second fraction. I've turned it into multiplication, and I've flipped this to be my numerator and factored out a GCF of 7. So that leaves me with 7r plus 2, and this is now my denominator. The GCF was 7, leaving me with 7r plus 3. Okay? All right, this still needs to be factored, though, and there is no GCF, so I'm going to have to use the grouping method. All right, so I'm just going to quick run through that in case you're still looking for examples of the grouping method used. I'm making a list of the factors of negative 168, and that's because negative 24 times 7 is negative 168. And I need to choose the two of those factors that add up to negative 53, which would be negative 56 and 3. You can find those quickly using the calculator. All right, so that's the fastest way to do that. So what I'm going to do is then I'm going to replace that middle term with a negative 56r plus a 3r minus 24. And now I'm going to factor using the GCF method. 7r is my GCF of the first two terms, and 3 is the GCF of the second terms. So I'm going to end up factoring that numerator, and I will have an r minus 8 and a 7r plus 3. And there's nothing else about this that I can factor any further. All right, so now it's a multiplication problem, so I can cancel things if I've got anything alike in my numerator and denominator. I've got a 7r plus 2 in both the numerator and my denominator. I've got a 7r plus 3 in both cases as well. And I've got two 7s. All right, so the only thing that's going to be left behind is the r minus 8. So this whole expression really just equals r minus 8. All right, so those three problems are not available for you to choose to do, but they are examples for you to use as you start to do some of these other ones. So again, just a quick recap. What you need to do is choose 2 of the yellow problems, 4 of the green problems, 3 of the orange problems, and you do need to do 1 of the red problems on the back page as well. All right, scan and submit them to the sub-assignment in Google Classroom, and then if you finish that early, you can start your homework. All right, have a good weekend, guys. I'll see you on Wednesday.